All right, I think it's time. Welcome. This is Calc 2. I hope you're in the right place. My name is Professor Stecker. That's how you say it. I hope you don't mind. I'm going to do everything on the screens, so I hope that you can all see it all right. I like to use the screens because I am, as we speak, recording what I'm doing on the screens, and I'm going to post it after the fact just so that you can see it later on. If your notes aren't good or whatever before a test or something, I'm going to post them on YouTube. So please like and subscribe. Let's talk about the syllabus. This is the first thing I gave you. So this is Calc 2, which is sort of what you think Calc 2 is. It's mostly about integrals and sequences and series. Those are the major topics. You don't have to know anything about sequences and series. Hopefully you know a little bit about the integral, but that's what we're going to do. Let's just go through the syllabus a little bit, and then I think we can get it started. So my email address you can see there, cstecker@fairfield.edu. That's the best way to contact me, and this is also the way that I'm going to contact you. I will send emails to the class every so often. So please read your Fairfield U email. Some people tell me like, I never read that email account. Read it, because that's the only way, I'm not going to text you or anything like that. So read them emails. My phone number is there. Don't call me. I mean, you can call me, but nobody ever does. And that's kind of the way I like it. No, feel free to call me, but don't. Send me an email. It's better. That's my office phone number, which never rings, and that's fine with me. My office is Banno 17 on the ground level. That is in this building, but you can't get there from here. It's sort of like in a basement, and that basement doesn't exist in this part of the building, so you got to go that way first, and then all the way down. I can see the library out the windows of my office, so it's on the library side of the building, all the way down. My office hours are written right there. This includes right before class every day. So I hope that some of those times is convenient for you. If none of those times work for you and you need to come and see me for whatever reason, then send me an email and we can work something else out. And the office hours, you can come by and talk to me. That's what I will expect. But if you prefer, you could also, we can do it on Zoom if you don't want to walk over for some reason. The Zoom link is right there. And there is a link. This QR code will bring you to the class website, which you will want to go to at least every week, because that's where I'm going to post the homework assignments. I'm not going to be using Blackboard for this class because Blackboard I don't really like Blackboard. I'd rather just do the website myself. So if you go to our Blackboard page, there's nothing there really except a link to this same page. So go over there. That's got everything that you need, which includes the homework assignments, and also that's where you can find links to all the videos from class that I'm recording each time. All right. The textbook is there. I hope that you all got my email a couple weeks ago concerning the textbook. It is Stewart Calculus by Stewart. The 8th edition was just Stewart. Here's a fun fact. Stewart, this guy, he wrote this textbook a long time ago, and it's been very popular, and he's gotten fabulously wealthy based on selling this textbook. Most people, I would not suggest writing textbooks as a way to get rich, but he managed it, and he recently died, but they're still putting out new versions of the book. So Stewart is no longer if you got the newest version is the 9th edition, and it's Stewart and Clegg and some other guys are listed. They are still living, but the money is still accumulating in Stewart's bank account. Anyway, I wanted to give you all the option to get the old version, the older edition, written by only Stewart, versus the newer one, because the older one is far cheaper. So if you subscribe to the university, I forget what it's called, the bookstore thing where they just give you all your books automatically, then you'll get the new one. but you can also get the old one. And when I make up the homework assignments, I'll just they will be problems from the textbook, and they change the problems a little bit, but usually they just like put them in a different order to make you buy the new book. So I will have 2 versions of each assignment, one for the old book and one for the new book, but they'll be the same problems. I hope that that's not confusing. I'm just trying to save everybody a buck. All right, anybody have questions about the book? Has any of you been able to see the book with the bookstore plan? I heard that some people were having issues with it. Have any of you tried to do it?
Yeah, I can see it there, but there's no link to click it and actually like go to it.
Yeah, I can like see that I have it, but I can't get it.
All right, has anybody successfully done it? All right, I will try to figure something out. I got an email from somebody at the bookstore saying something might be wrong with this, so I guess something is wrong with it. You won't really need it until, principally you'll want to use the book to get the homework problems, and our first assignment will be due next week on Wednesday, so there's still some time. And if it's not worked out, I can just send out the problems illegally to you all. All right? Great, that's about the book. So maybe we'll just look at this thing that says the course content. This is the official course description. I didn't write this, but it says the topics include integration by substitution and by parts, areas between curves, volumes of revolution, inverse functions, logarithms, exponential functions, inverse trig functions, indeterminate forms and L'Hopital's rule, improper integrals, infinite sequences and series, including convergence tests, absolute and conditional convergence, power series, and Taylor series. So I know, if you took the Calc 1 here, then this is pretty much a direct continuation of that course. I know some of you are coming straight from high school, and in that case, we may be repeating some stuff that you've already seen. I guess it's possible there could be stuff that I assume that you know that you haven't seen before. So we're going to try to kind of gather ourselves together, and eventually we'll all be on the same page. But I'm going to try to, today we're going to do some review stuff just to overview what I think you already know. And hopefully you do already know what I think you already know. And if not, I would be happy to, go through stuff more in depth with anybody who would appreciate that kind of thing. I'm going to assume that nobody knows anything about sequences and series, although maybe some of you do. And I'm going to assume you know the basics about the integral and the basics about the derivative also. All right, let's talk about mastery-based assessment. It says this is weird, so pay attention. This is weird, so pay attention. This is about how I'm going to do the grading for this course. Most of your grade will be based on this mastery-based assessment thing. This is not, I didn't invent this way of doing grading, but it's a sort of weird new way that people have been trying out, and I think that it works out pretty well. So here's the idea. This other thing that I handed out is a big checklist. This is a list of all the topics that we're going to be doing throughout the semester. Maybe some of these look familiar, some of them don't. That's totally fine. But these are the topics for the semester. And as we go through the semester, you will be checking off things from this list. And the idea is by the end of the semester, hopefully you have checked off everything. For each one, you can get 1, 2, or 3 points. 3 points is like full credit for one of those topics. If you can get partial credit if you're not doing it perfectly right. And by the end of the class, I will just add up your points here, and this is what your grade is based on. How many of these things did you get checked off? All right. Now, the way that you check them off, it says the course material has been broken down into about 30 different specific objectives. There they are. There's 27. Each student's progress on each objective will be tracked in a checklist. This is kind of a record-keeping nightmare for me, but I can handle it. I will be keeping track of every one of you, all of these items, how many points you have for each one. You should keep track yourself, so it's important that you keep this piece of paper, and as we go through, you're going to be checking these things off. I will also do it on my end, so if you ever lose it or whatever, I'm happy to give you another one, but you should be keeping track of which ones you're checking off. It says, students demonstrate their mastery of each objective by correctly answering quiz questions, each of which is labeled as assessing one specific objective. The idea is we're going to have a quiz every week, And those quizzes are your opportunity to check things off of the list. Every question that I give you on a quiz will be specifically indicated, like this is a number 8 about the natural logarithm or whatever. And that question, I will grade it 0, 1, 2, or 3 points. And after you get the quiz back, you will know how you did on that question. If you get 3 points, you can check it off of your list, and that means you are done with that thing for the rest of the semester. Yeah.
Does that include finals? Like if by final we've completed everything, we don't have to take finals?
Yeah, so the idea we are also going to have exams. There's going to be one midterm exam in class in the middle of the semester and the final exam. These are simply more opportunities to check things off the list. So that means, in the best case scenario, you will get to the end of class and have everything checked off. And in that case, you won't need to take the final exam. Although now that I say that, I'm not entirely sure that that's true. Just because we're having a quiz every week on Friday, it may be that we do stuff in the last week that I'll make it work out. So, just turn in the corner. She left one here. She's going to be back for it. If everything goes perfectly, this means you won't have to take the final exam because you will have already checked off all of the items. These things, you have an opportunity every week to check some off. So it says, if a student answers, there's a little typo here. It says if a student answers an exam question correctly, I'm reading in the middle of the middle paragraph there. That should say quiz question or exam question. The exams are treated the same as the quizzes. Once an objective is mastered with full credit, the student does not need to answer any more questions on future tests and quizzes addressing that objective. The idea is every test will include questions from all of these topics, but if you've already checked that one off of your list, you don't have to do that question on the test because you've already gotten full credit for it. All right. This is really the sort of the purpose behind this somewhat weird method. It says in the last paragraph there. There's no penalty if a student answers a question incorrectly, but this objective will remain unmastered. So if you take one of these quizzes or one of the tests and you get something wrong, you're not screwing your grade by getting it wrong, right? It just means that you didn't check it off the list yet. So you could even, in theory, just get zeros on everything the first half of the class. Your grade is not screwed. I would say, like, you personally are kind of screwed because you're going to have to accelerate your learning. You probably don't know anything, and you're going to have to learn everything at the end. But the idea is there is no penalty for getting wrong answers as long as you eventually get it right. And I think this is really like this is the way that people actually learn things successfully in life anyway. Like, nobody gets it right the first time, and from my point of view, I don't even care if you get it right the first time. Like, what I care about is that you get it right eventually. So that's the way that the grading system is based on. Yeah.
So, like our first quiz on Friday, is it gonna just have like what we've covered, or is it gonna have every single topic?
Yeah. So when I say every test has everything, it's only the ones that we've covered already. I guess some of you probably know some of these topics already. You can't do them early though, just because I'm not gonna make those questions on the earlier tests. We're not gonna have a quiz this week, but we'll start next week. Yeah.
So if you receive like a 2 and then in the future receive a 1, you get to keep the 2, but in the future you get a 3, you get to go up to the 3.
Yes. Yeah. So if you redo a question that you already did, this is an opportunity to increase your score, but I won't tank your score if you do badly the second time. Yeah. Is that a question? Itchy shoulder. All right. So about the quiz, it says, there's one more little detail here. Each Friday, a short quiz will be given. This quiz is, I'm on the flip side of that page now. It says this quiz will be an opportunity to earn mastery points on new and old items. And each quiz, I intend for these quizzes each week to be fairly straightforward. We take maybe the first 15-20 minutes of class, do the quiz, hand it in, and then we go on with the rest of class. So this is not meant to take up the whole class period every Friday. What I plan on is the quiz every Friday covers all the new stuff that we did from the week before. So the basic idea is we do new stuff one week. That stuff will be on the homework, which will be due on the following Wednesday. and then that Friday we have the quiz on that same stuff. So hopefully you do the homework on Wednesday, and the quiz is not meant to be like extra super hard. It's like if you did the homework on Wednesday and everything seemed to make sense to you, then you should be able to do well on the quiz, which will happen 2 days later. Unfortunately, this means if you didn't do well on the homework, there's not a whole lot of time to correct before the quiz happens on Friday. But I'm going to leave it up to you. I think you can tell if you're doing well or not on the homework. If you feel like you're doing badly on the homework, you should talk to somebody, get in touch with me if you like, and try to get better right away. Yes?
So like if we're doing the homework earlier in the week, we can go to office hours and like check with you.
Sure, yeah.
And then like that way we know we're like doing.
Yeah, that sounds like a good idea to me. It says each quiz will consist of one question from each new topic covered in the previous week, along with, so this is a little complicated and I hope that I can manage doing this, along with one old question of each student's choosing. So every week for the quiz, I will give probably 2 or 3 questions which everybody has to do. Those are the new ones. And then each of you during that time, during the quiz time, can try again one old one. And I'm going to bring a stack of old ones. And you will each tell me which old one you want, and I will give you an old one. All right? I hope that this will work out. There's kind of a lot of you. I think it'll be okay.
That's like if we had like our checklist and we saw like, oh, like last week I got like a 1.
Yeah, right.
And then we could
Yeah, because otherwise there isn't, I keep saying like, oh, you can try them again, but really there isn't any chance to try them again except for this. So if you get one wrong, say, the first week, there's probably going to be the first 3 things are the review topics. Those will probably be on the first quiz. But if you get one of them wrong, that can be your old one for the following one. Yeah.
Are we allowed to bring like the checklist in when we're taking it?
Yes, you definitely should bring this with you just so that you know like which ones you've already gotten and which ones you still need to do. And of course, if you find yourself doing a quiz and you have no checks missing from previous weeks, then just don't do an old one. That's fine with me. Yeah.
Do you get your points from like how like correct one question is, or do you have to get like 3 like of the like, same kind of question right?
Typically, I'm just going to give you one,
Okay.
and if you get that one right, that's good enough. Yeah, right. Some of these I can imagine if it's a sort of an easier type of thing, like just the very first one, simple derivatives, I might give you more than one of that just because you can do them in a few seconds if you know what you're doing. So, but I would say in general, these problems will be fairly involved, so I'll just give you one. Any other questions? I know this is weird. I hope that this seems like a good system to you. I really, it's kind of a lot of quizzes. I hope that, I know that taking quizzes all the time can be anxiety inducing for some folks, but I also feel like, the whole point of this system is I am trying to do this evaluation a lot of times. I don't know why that happened. Doing it a lot frequently, right? Just so that you have more and more opportunities to do the old ones. That's the idea. All right, great. Let's, one other thing you reminded me. Since you're going to bring this with you to the test, please don't write other stuff on this. Like, don't use this as a note card during the test. If I want you to use a note card, I will tell you separately, but keep this nice and clean, if you will. If you ever get yourself off track, if you're not sure if you have this or that checked off, ask me and I'll be happy to tell you. You can also find other, there's a PDF of the list on the class website, so if you ever lose it or whatever, that's where you can get it. All right. It says there's something about the homework. So the homework is going to be not this weird grading system. It will be much more traditional. Sorry, my doc has appeared. I don't know what's going on. No, there it is. The homework is just going to be every week there's a homework assignment. You write all your answers. I grade it. You get partial credit on the questions, and you get a traditional grade on each assignment. These other quizzes, you don't ever really get a grade on the quiz. It's just like you either checked it off or you didn't. You get grades per question. All right. The homework. Can we talk briefly about the homework? Actually, did I already say about the exams? There will be an exam. You can see the date here on October 25th. Put that in your calendar. And then also the final exam at the official final exam time. These exams are basically just like a giant one of those quizzes. The exam will have one question from every topic on it. You should only do the ones that you need to do. And ideally, even for the midterm, if everything's going perfectly, then you won't need to take the midterm. And if everything is perfect at the end, you won't need to take the final exam. More likely, the midterm, we'll take the whole class, but more likely you will, when it comes to the midterm time, you'll already have most of the stuff done. So you're not going to have to do every question. You're going to have to do half of them or something. That's the idea. All right. To tell you the truth, I have no idea if this system is going to make everybody get an A or not. I'm not sure how it will work. Is it too easy? Does it seem too easy to you? I don't know. Just have to wait and see. If everybody gets an A, that's what happens. I'm not going to tank you all afterwards because of my poor choices in my grading system. I got tenure, so what are they going to do? I can give you all A's anyway. All right. For the homeworks, it's going to be every Wednesday, not including tomorrow, and the homeworks will be submitted electronically. And I would like for us to do a little trial of the electronic submission just to make sure that everybody is okay with it. Just to make sure everybody knows how to do it. So you should do this entirely on your phone. And the way that it works, we're going to use a website. They have an app, but you can just use your browser also, called gradescope.com. Gradescope.com. The way that this works, doing math electronically is a real pain if you have to type stuff out, but I don't want you to get into that. So the way Gradescope works is you write your homework answers like you normally would, just by hand on paper, and then you take pictures of the pages and send them into Gradescope. This is how it works.
If we do our homework digitally, can we use screenshots?
That's fine, yeah. If you don't want to write it by hand, that's totally fine, but that tends to be the easiest. So you should have gotten an email yesterday from Gradescope about how to log into your account. You probably have to make a password. There's a link in that email about setting your password. I would like for us all to take a few moments and do that right now, just so that everybody is clear on how to do it by the time we get to the first real assignment. If you log into Gradescope, you should see a dummy assignment in there for you to complete. And your job on this dummy assignment is to write something interesting about yourself and submit it. You should just write something on a real piece of paper and then take a picture of it. That's how you're going to submit your assignments. Or if you like, you can write it, digitally and then screenshot it or something. So I would like to just take a few moments right now and try and do this. I'm going to walk around and make sure everybody is doing okay. If you have problems logging in or whatever, that's what I'm trying to straighten out right now. If there's some kind of serious disaster, you don't really have to figure this out until the first assignment is due, but I figure we might as well work it out now. See how it goes and let me know if it's not working out.
Well, no, that's not what it is. It's totally new. Totally new. I'm writing it down. And then reset password and said, I'm not doing email. And I just never got the email.
As long as you feel like it.
Okay.
It really doesn't work. You good?
Yeah.
All right. Nice.
Yeah.
You guys good? I'll give you another minute or so, and then we can get on with it. All right, I think I want to continue here. Let me know if some people are still doing it. That's fine. Let me know if it never works out for you. I would be happy to sit down with you and try and make it happen. Just a few more things from the syllabus. So this is how we're going to submit the homeworks, just like you just did. The homeworks are due on Wednesday evening at midnight. So that means that it's my intention that you sort of work on the homework at the beginning of the week. It's due on Wednesday, but it's totally fine with me if you come to class and you're not quite done, but you have like a few little questions left over. We can talk about it, and then you send it in Wednesday night. So that's my idea with that. I would be happy to, even if you think you're doing it right, feel free to show it to me and say, hey, is this right? And I will tell you if it's right or not. There's a little note here about office hours. So it says the professor regards visits to office hours as part of the instruction for this course. Like this is, I consider you guys coming and chatting about homework questions or whatever. That's like an ordinary thing that everybody in this class will want to do from time to time. It's certainly like you don't have to come and talk to me if you don't want to, but I hope that you don't have the attitude that like you can only ask me a question if you're totally screwed or something like that. That I can remember like when I was in high school, that's kind of how it was. Like I never wanted to talk to my teachers outside of class. I certainly never wanted to be seen talking to a teacher outside of class. That was a sign that like something was seriously wrong in my life. But I hope that that's not how you feel. This is not, I think like college in general is not supposed to be like that. And certainly like that's talking to you on an individual level is like much more interesting and fun for me anyway. Like I consider that to be just an ordinary part of how we do things. Like I said, you don't ever have to talk to me if you don't want to. That's totally fine too, but that's how I feel about that. You can see the grading percentages there. The checklist is 75%. The homework is 25%. So that's simple enough. And then just a few little things on the back. Should I show my work? The answer is yes. When we're doing these types of problems, like I give you a bunch of homework problems, I already know the answer. So you don't need to tell me the answer. You need to demonstrate that you know how to get the answer. So this will involve telling me the answer, but that's the end, right? There's other stuff that you should be writing down. So don't just write down the answers. If I can't tell the difference between you actually did it or you just copied the answer from someone and wrote the answer, then you're not doing it enough for me. All right. Now, there probably are going to be questions from time to time where there's really nothing you can say as far as showing your work, and that's fine, but I think we all know the difference. A little thing about attendance, there is no percentage of the grade based on attendance. So attendance does not directly affect your grade. But I will say, if you miss class, that's fine. But I consider it kind of your responsibility to get yourself caught up with whatever you missed. If you miss a quiz, then you definitely ought to talk to me and see about rescheduling. If you want to do that, it should be before you miss the quiz. Although it's not a real disaster if you just completely miss a quiz, because it doesn't screw your grade. But attendance is not part of your grade, but it's on you to deal with whatever happens based on missing class. I've tried to make it very easy for you. I'm posting this business on YouTube, so you can always see the class after the fact. If there are assignments or quizzes or whatever, I consider it to be your responsibility to sort of get in touch with me about making stuff up that you miss. All right? Excellent. I'm always enthusiastic about helping out. I don't consider it part of my job to sort of hassle you about stuff. If you miss stuff, that's your own business to deal with. All right. And then a bit about, did I put that office hour thing in twice? Wow. I didn't mean to do that. It's in there twice. I really mean it. There's a little bit of advertisement for the counseling services. Did you know that Fairfield University has free counseling services? Free, in quotes, like nothing here is really free, but it's sort of included in the big pile of money that you've already paid. So just a little something to keep in mind. College is a weird place, especially if you're new here. I think Fairfield is a great place, but it is definitely a bit of an adjustment, and I hope you will take advantage of that if you find it helpful. I have found it helpful to see a therapist every so often. Sometimes when I'm talking to my wife, she says, maybe you should talk to Stacy about that. And that's, I'm glad that's a true story. All right, I think that's all I have to say about the syllabus. Are there any questions about any of that? I hope that everything sounds clear. I know the grading is a little complicated, but I think it'll be great. We'll see. One thing I didn't mention, I should have made a specific mention of this. Sorry to be a tease here. On the quizzes and the tests, no calculators. It says that on the paper. I didn't say it out loud. So this means that the types of problems that I'm going to give you will not involve like multiplying big numbers together. I say no calculators just because I know that, especially in a calculus class, there are people with fancy calculators where the calculator can basically do everything for you. And in your own personal life, I say go for it. I mean, that's what calculators are for. But for the purposes of like taking a test in a math class, I say don't go for it. I want to know what you are able to do yourself. So there will be no weird numbers in the questions. On some of the homework problems, there might be, because I assume you're going to use a calculator on the homework problems. But for the quiz and test questions, there will be no weird numbers, and I will expect you to leave your answers in some kind of weird, unsimplified form when there are weird numbers in the answer. So I think as we do examples, in class, I think you'll get a feel for what kinds of things I am looking for. If you're ever unsure on the test, like do I need to simplify this more, you can ask me. My answer will almost certainly be no, you do not need to simplify it more. My kind of philosophy about this class, this is a class about calculus, right? This is not a class about simplifying things. A lot of times you can do a calculus problem where like you do the derivative, which takes you 30 seconds, and then you simplify for 5 minutes after that. I'm not into that because I assume that you already know how to simplify things. Maybe you do, maybe you don't, but that's not what this class is about. This class is about doing the calculus part. The simplifying I leave up to the high schoolers, all right? I should say, if you don't know how to simplify things, you may be screwed in it for other reasons, but I'm not going to just straight up ask you to simplify stuff. All right, great. Let's get to it then. So, like I said, sorry, my screen is acting up. I hope this is working. I would like to start with some review topics, and we might as well, inspired by the checklist there. So when I say review, I mean this is stuff that I assume that everybody already knows what I'm going to say, at least for today. I hope that that's true, and if not, that's totally fine. Just, I would encourage you to set up an appointment. We can go over stuff or whatever, or just try and learn it yourself. By the way, I would suggest, I can see folks are reasonably well prepared. I would suggest, take notes during class. If I'm like rattling along and you're not clear on what's going on, please interrupt me with questions or whatever. I hope that you will feel comfortable to do that. All right, so we're going to start with simple derivatives and integrals. Simple derivatives and integrals. So you should know, first of all, you should know what it means when I write something like that. D over dx means the derivative of x to the n. This is what we call the power rule. You absolutely should know this. When you write it as a formula, it looks like n x to the n minus 1. Now, I don't necessarily think you should memorize that formula, but you should definitely know this rule. So, for example, that means the derivative of x to the 5 is, any master out there knows the answer?
5x to the 4.
Yes, welcome to college. 5x to the 4. I don't know if you're new here, but 5x to the 4 is correct. So that's what this rule says. When you take the derivative of a power of x, this thing means whatever the number was up inside the exponent, that same number becomes the coefficient, and then you decrease the exponent by 1, just like that. All right, this is the simplest of the derivative rules, and we're going to use that probably every day, so you definitely need to have that memorized, I suppose. There's also, these can be slightly more interesting if it's something like 8 square root of x? Anybody recall how to handle the square root in a problem like this?
Yeah. You can write it as x to like the half.
Yeah, the square root is the same as a 1/2 power. So this, I didn't do the derivative yet, but all I did was rewrite the whole thing, but instead of root x, I write as a 1/2 power. And now I do the rule about the exponent comes down to the front. What happens to the 8 that's already in the front? Yeah.
4.
Yeah, the 8 becomes 4. You move that 1/2 down into the coefficient and you multiply it onto the existing coefficient. So this 8 becomes 8 times a half, maybe just to be very clear about everything. You can write it as 8 times a half x, and then what's the new exponent?
Negative 1/2.
Negative 1/2. Yeah, you subtract 1. So it used to be 1/2. I go minus 1. 1/2 minus 1 is negative 1/2. All right? 8 times a half is 4, of course. 4x to the negative 1/2. All right, so that's how I would write my answer. I don't care if you leave the negative half exponent. Some people, I don't know why, some people are trained in high school. You can't leave it like that. You have to write 4 over root x. You can do that if you want to, but I will not be impressed, and I will not expect you to do that. To me, this is an easier thing to make sense of. All right, so this is the power rule. All right, there's also the power rule for the integral. So maybe I'll put that up here right next to that one. So this is the integral of a power of x, integral of x to the n dx. And for this rule, you do kind of the same thing, but the opposite. So the previous one said you decrease, it said you multiply the exponent. I couldn't think of the word. You multiply the exponent in the front, and then you decrease the exponent by 1. To do this backwards, you increase the exponent by 1, and then you divide the exponent in the front. So the rule here is this. And then you put the plus c because you are all good little boys and girls, and you remember to put the plus c when you do the integral. Sometimes it matters, almost never does it matter, but it should be there technically. All right? That's the power rule for the integral. And I hope that everyone is intimately familiar with these because we're going to use them all the time. So for example, just a simple example of using that, 3x to the 5 plus 4 dx. This is an integral with a plus inside, so I hope that you know when you have things added together in the integral, you don't have to do any fancy business, you just do each one separately. So I can just handle, maybe I'll write the answer down here. You can just do each one separately when they're added. If they're multiplied, you got problems, but if they're added, no problem at all, you just handle each one separately. 3x to the 5, I do that rule. I keep the 3 like it was, and I go 1/6 x to the 6, all right? The original coefficient stays as a coefficient, and then you do the rule, which I scrolled away at this point. Come on. I'm doing the rule at the top right there. The 5 in the exponent becomes a 6, and you divide by the 6. And then I go plus 4. Anybody remember? This doesn't exactly look like this rule, but what if it's just a constant?
You just have the x.
Yeah, you just add the x, she says, by which I think she means you multiply by x.
Yeah.
Right. So any constant inside an integral, I hope you remember, just becomes that same constant times x. And then I put the plus c, of course. I do have a PhD in mathematics, after all. I put the plus c. All right. This is what I call simple derivatives and integrals. So that's it for this this section. I hope that you also know things like the product rule, the quotient rule, the chain rule for derivatives. I'm not going to make you do those on the quiz because pretty much this whole course is about the integrals, so those things will not come up as much. Although the chain rule is one which will come up, but we'll sort of cover it as needed. Those will not be specific test questions. All right, one other thing in the topic of simple derivatives and integrals is the trig functions. So these ones you should know. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. And these are a little confusing just to keep it all straight. Which one gets the minus sign? I'm not sure. Does anyone know some kind of cutesy trick? I just have it memorized. Yeah?
All of them with co.
If it has co and you do the derivative, it gives you a minus?
Is that true?
Cotangent.
Yeah. All right. And if you do the integral, it's the other way around? All right. Is that helpful to anyone? I don't know. I just remember this. There are other trig functions, of course, but those ones we are not going to, I will not assume that you have them memorized, like what's the derivative of cosecant or whatever. Those are not going to come up all that often, and when they do, you can just look it up in a book somewhere. If somehow I wanted you to know that while you're taking a test, I would just give you those formulas. But the sine and cosine, you should definitely know. Derivative of tangent is secant squared, which is fairly useful. Comes up often, but as far as things to have memorized, I'm going to just assume that you have these two memorized. I, in general, am not big on making you memorize stuff because I think it's not terribly realistic in terms of how people do math in the real world. People look stuff up all the time. And anyway, you should know the integrals of these things. The integral of sine x is minus cosine of x plus c. And the integral of cosine x dx is sine of x plus c. All right? That's those. So these can all be, combined in weird ways. Something like integral of 3x to the 7 plus 4 cosine x dx. Again, because they are just added together, you can just handle them separately and use the appropriate rule for each one. So 3x to the 7 will become 3 times 1/8 x to the 8, and then 4 cosine x becomes 4 sine x. And then I put the plus c. So that is the kind of thing that I'm talking about for item number 1 on the list. And I hope everybody feels like these are easy. If you already know these rules, they are easy. If you're a little shaky on the rules, then you may need to do some review, but not too tricky. Any questions about that? Any questions about, do I also need to know how to do this and this and this? No. I will not assume that you know any of the sort of weird rules for sine and cosine about like the sine of the sum of two angles. There are formulas for that, which you probably learned in high school, but we're not really going to use those much. I will assume that you know sine squared plus cosine squared equals 1. That's the important one. Other ones, more obscure, won't really come up. All right, so that was item number 1 on the list. Number 2 says the definite integrals, in particular trig values. So the definite integral, all of these integrals that I've been doing here are what we call the indefinite integral. When you do the indefinite integral, that's the one without the little numbers on it. And the answer of an indefinite integral is a function with a plus c. The definite integral is the one which does have the little numbers in it. And the answer of a definite integral is a number. And it represents the area under the curve of the function you're talking about. So maybe I'll put a little heading here. The definite integral sorry, I'm looking. I have a hard time keeping straight when the class is supposed to end. This is like a longer than usual class. So we end at 1:45. I'm just saying that for myself. The definite integral is like one of these. You know, it would typically look something like that. Integral from a to b of f of x dx. And what that means is it is a number. The answer is a number. And it represents something like, if I have a function here, and a and b are two x values, the definite integral represents that area, the area under the curve. So this is this area. All right, I didn't mention it, but I hope everybody knows the derivative. The meaning of the derivative is the rate of change of something, which is important in many different applied situations in science and business and whatever. The integral represents the area of a weird shape, which also turns out to be very useful, although it is a bit more abstract. I mean, it's not immediately obvious who cares about what the area of some weird shape is, but it turns out the integral also comes up all the time when you're doing, say, physics and even business type calculus. Anyway, this is not, I hope everybody knows, the definite integral is not literally the same as the area under the curve. They can be, they're related, but I will just say any area above the x-axis counts as positive when you do the integral, and below the x-axis counts as negative. Of course, area itself is always positive. The area of any shape can't be a negative number, but you can get negative answers when you do the integral, and that indicates area that's below the x-axis rather than area that's above the x-axis. And weird things can happen if the function goes, like parts of it are above and parts of it are below. For example, if I have something like the integral from 1 to 3 of some function, f of x dx, where the function looks weird like this, maybe. Right? In this case, the function actually crosses the x-axis and something slightly weird happens in the integral. What is the integral? It's actually this as a number is not equal to the total shaded area here. Can anyone say what is it in terms of those areas?
The net number?
Yeah, it's like the net area if you count this one as being positive and you count this one as being negative. So actually in this case, this would be sort of like this area minus this area, right? This bigger one here would be subtracted because it's negative below the x-axis, all right? So people generally say the integral represents the area under the curve, and that's more or less true, although sometimes some weird things can happen like this. All right, great. And I will just say, in real life, integrals come up all the time in terms of like doing problems that come up in science or whatever. But actually, the integral in real life is usually very hard to measure because in real life, typically these functions that you're talking about don't have equations. Like if I'm trying to use, say, calculus to analyze the performance of my business or the performance of my YouTube videos, I can look at a graph of my YouTube views over time and it goes up and down or whatever. how easy would it be for me to find the area under the curve of that graph? The answer is not easy at all, because it's not, like, even if you know how to do the integral, you need like an equation to use to do the integral, right? You do the antiderivative or something. But in the real life, most things that we care about analyzing don't even obey equations at all. So finding the integral is actually a hard problem in real life. And I'll just leave it at that. This is something, if you're interested in, this is what things like Simpson's rule was invented for. I don't know if you heard of that. But we have a whole class called numerical analysis, if you're a math major, you can take, which is about problems related to that sort of thing. Okay, anyway, if you know an equation for your function, though, you can, without too much trouble, find the definite integral. There's a nice little trick for it, and it's called the fundamental theorem of calculus. That's how important it is. The fundamental theorem of calculus. It tells you how to actually find the area under the curve if you know what the equation is. This is the relationship between the integral and the antiderivative. There's actually two different versions of the fundamental theorem of calculus. I don't know if you've seen both of them in high school. One is kind of the more standard one, which is the one we typically use, but there's another way of writing it. So here is the first version of the fundamental theorem of calculus. It says the derivative of the definite integral from a to x, f of t dt, equals something. I will fill in the blank. This is what the fundamental theorem of calculus is. This is kind of the weird form of it. It says if I take the derivative of something where the x is up here, this is about, remember the derivative represents the rate of change. This is about how fast is the area changing. If I were to change this x a little bit, how fast is the value of the area change? This is a very weird question to ask, and it's not at all obvious why this should be important for anything. But if I were to draw a picture representing sort of what that question is all about, the picture would look something like, okay, I have my function, f of t, and I'm talking about the area when I go from some value a. Usually I go like a up to b, but here I'm going from a up to x, and I imagine that the x is a variable, and I'm going to be changing the x a little bit and measuring the rate of change. So I go a up to x, and I'm talking about this area here, right? And the question being asked sort of on the left about that, what is that derivative, this very strange looking derivative of the integral? The question means this represents the rate of change in the area when we change x a little bit, right? That's what derivative means, of course. It means how fast is this function changing if you were to change the x a little bit, all right? So I imagine when I'm doing this derivative, it means I look at this area here and kind of imagine what would happen if I just sort of push the x out a little bit here to, you know, when we're doing derivatives, like the definition of derivatives, you might write something like x plus delta x or whatever. We're not going to get into the details, but how much would the area increase if I were to push that x out just a little bit? And what's the answer? Well, I don't know. The answer is like, yeah, it would increase a little bit, I guess. How much would the area change by? It would get a little bit bigger, right? But the important thing is, check it out. How much bigger would it get? I would say this area, this sort of extra little blue bit, is kind of a large area. If this red line had been way down here, then it would be much smaller, the extra area that I get, all right? The extra area that you get depends on how high up the curve is on this end, right? I hope that that makes sense to everybody. So I will say the extra area, sorry, trying to get my color straight here. The change in area depends on the height of the function at x. X is the value all the way to the right, on the picture. And if that is a lot of height, then the area is going to change a lot. If that's a little bit of height, the area is going to change a little bit. If that height happens to be 0, the area will not change at all right? What is the height called when, of course, this is x here, right? This height is, that's f of x, isn't it? That's what f of x means. It means that height. And the answer up here, I just filled in the blanks. This is the first version of the fundamental theorem of calculus. It says, the weird thing on the left is how fast is the area going to change? It is equal to this height. This should not seem totally crazy, although it's a little bit of a surprise that these are just straight up equal. What I said before was, if this height is pretty big, then the change in area will be pretty big. And if this height is pretty small, the change in area will be pretty small. So there's definitely a relationship between them. The fundamental theorem says actually they are straight up equal to each other. That's the relationship between them. All right? I hope you don't mind this little diversion. In my experience, people either don't talk about this at all in high school, or maybe they mention it once and then immediately forget about it. But this is the first version of the fundamental theorem of calculus. All right? And this is like one of the great sort of deep insights which led to the creation of calculus in the first place, was this very strange, it's weird to even be asking this question in the first place. What happens if I were to change, what happens to the area if I were to change one of the endpoints a little bit? It turns out this is extremely important though. All right, so this is sometimes referred to as the fundamental theorem of calculus, which I'll write FTC version 1, the first version. That's what our book calls it. The fundamental theorem of calculus, the first version. This one is super important, and I hope that everybody understands the idea behind it, but we're, to be honest, not really going to use this one very much at all. The more useful one, at least for our purposes in this class, is the fundamental theorem of calculus version 2, and this is the more familiar one, which I hope that everybody knows. I'm not going to write any derivatives. It's just written like this. If I have the definite integral from a to b of f of x dx, it is equal to a big F of b minus a big F of a, where the big F is an antiderivative of the little f. So this says how to find the area under the curve. It is actually equal to this big F function where you plug in the b, and then you also plug in the a and you subtract the two values. This is what I hope you are all familiar with. I thought it might be nice to talk a little bit about where this one comes from. It turns out this one comes directly from the first one. You can demonstrate this. So I would like to, let's sort of write this thing here. I'm going to write a little proof of this. I hope you won't mind me using the P word on the first day of class. We are, from time to time in this class, going to talk about proofs of things. It's something that I came to college as a math major. No, that's not true actually. But I was really into math when I started college. I thought maybe I was going to do music or maybe English literature, but I settled on math. But I remember I was really annoyed when my professors wanted to talk about the proof of things, because I was like, I believe you already. Like, you don't have to convince me. And I hope that you should more or less believe me when I tell you things about mathematics. Although I'm not very good with numbers, so you should check my math when I'm like multiplying things. But the purpose of doing the proof is not so that I can convince you that it's actually true. It's more so that you can learn how to think properly about these things and use these ideas in different contexts and different situations. That's sort of the reason why we do proofs at all in mathematics, other than just like, otherwise you could just say true things, and if everybody believes you, then everybody believes you. But there is a reason for talking about proofs, and that is so that we understand things better. So here's a little proof of this. I would like to consider, well, let me just say something like this. I'm going to let g of x be this other weird integral. that appears in the first version of the fundamental theorem. And we're going to do some weird stuff to that. Of course, this equals... no, this does not equal f of x, but we know since the derivative of that thing, since this is by the fundamental theorem of calculus version 1, it means f of x is an antiderivative of g of x. Sorry, I wrote that backwards. I meant to say g is an antiderivative of f. Sorry, I'm off to a bad start here. G is an antiderivative of f. That's because g is this thing here, and what that says is the derivative of g equals f, right? The derivative of g equals f. That means g is an antiderivative of f, because the derivative of g is f, all right? All right, I think I said that right. And furthermore, if we plug x equals a, this would say g of a now, but the definition of g you can still see on the top, I hope. When I plug in x equals a, I get integral a to a, f of t dt. Can anybody say what that is? The integral from a to a?
0.
It is 0. Yeah, why is that? I don't know who said it. Yeah?
I mean, you're not like going anywhere. You're in the same
Yeah, if you think of this, if you imagine this as an area, it's the area from here to here. Like there is no area there. It's just from one point to itself. There is no area. This area is 0. That's because there's no area. All right? That's what g of a is. I'm looking at my paper here. Okay. Then, sorry, to be honest, I didn't think we'd quite get this far today, so I'm having to read my paper closer than I thought. That means that if I look at g of a minus f of x, sorry, then g and f are both antiderivatives of the little f. I already said that the g was an antiderivative of the little f. You can see that still on the top. And then this big f function that we had all the way at the beginning is also an antiderivative of the little f. So they differ by a constant. This is something that I hope you know from your calculus class. If you have two functions with the same derivative, they are different from each other by a constant, or any two antiderivatives of the same function. That's the whole point of the plus c when we do an antiderivative. Any two antiderivatives of the same function differ by a constant. That means g of x, I'm going to write it this way, they differ by a constant. So this is one way to say that. G of x minus f of x is a constant. And now if I were to plug in a, x equals a, it says g of a minus the big F of a equals a constant, but g of a is 0, that's what we said before. So this constant is negative F of a. I'm almost done here. Sorry, this is a bit of a struggle to tie it all together. That means, right here, I said g of x minus f of x is c, but then we figured out that c is minus f of a. It means g of x minus f of x is negative f of a, right? I'm just plugging the c in here where it goes. And now the very last step here is plug in b, and it says g of b minus big F of b equals minus f of a. That's plugging in x equals b. And then rearranging this gives you the formula that you want. It says g of b equals f of b minus f of a. That's the right-hand side. But the g of b, if we write the definition of this, it is a to b integral f of x dx. And so those things are equal. Sorry, that was a bit more of a struggle than I expected. This is how you get the second version of the fundamental theorem using the first version. It's basically a bunch of simple rephrasing and resubstituting various things. All right. They look different on paper, the two versions, like version 1 and version 2. But it turns out they are basically the same thing behind these various substitutions. All right. So anyway, I will just write this formula again. This you definitely need to, I suppose, have this formula memorized, but usually people don't memorize this as a formula. You remember what it means and how you actually do definite integrals using this formula. I got just a couple to try, and that should do it for today. So for example, if I have something like the integral from 1 to 4 of x squared dx, what is that? Now there's a special way that I'm typically going to write this, but the idea is you do the antiderivative and then you plug those two numbers in, the 4 and the 1. Here's the way that this is typically written. I am first going to do the antiderivative. X squared, the antiderivative of that is 1/3 x cubed. And then I put this little bar over here with the 1 and the 4. I hope this looks familiar to you. This is how we are always going to write the definite integral. And the meaning of this bar means in the next step, I'm going to plug in 4 and 1 and then subtract. All right? The bar is just a way of breaking this out into an extra intermediate step so that you don't have to do the whole thing in your head. You do the antiderivative first, and then I plug in. So my final answer looks like 1/3 times 4 cubed minus 1/3 times 1 cubed. The end. And this on a test or something, I would expect you to just leave like that. This is something I'm sure you could simplify if you really had to, but like I said before, without a calculator, I don't care if you know what 4 cubed is divided by 3 and so on. All right? I don't know if you feel foolish writing 1 cubed. I find that some people in this class, they really cannot resist writing another step where they like leave this part out because it's like it's scandalous to write 1 cubed and leave it. Okay? You do you, I say, but I don't mind leaving it. All right. So how about just another one? Now it says on the sheet there, definite integral in parentheses trig values. So here's a point where I would expect you to be able to evaluate some trig functions. For example, if I said 0 to pi over 2 of sine of x dx, I hope that you can do all of this without a calculator. First, you do the antiderivative. Antiderivative of sine is minus cosine of x. And I put the bar, pi over 2 and 0. And this you may want to review a little bit if you've forgotten how to do this. First of all, we are almost always going to be using radians in this class because radians are better. But every so often degrees will come up, but we are pretty much always going to do in radians. You know, maybe on the homework sometimes you're doing like a word problem which has degrees in it. That can happen. But as for me and my house, I choose the radians. And I hope that you remember how to evaluate various values of sines and cosines at various important values of x. So this, anyway, when I plug it in, it says minus cosine pi over 2 minus cosine 0. Make sure you get the minuses straight here. This minus here is because there's actually a minus in the formula when you do the fundamental theorem of calculus. This minus is because it's part of the antiderivative. All right, and then anybody actually remember how to do these? I have a minus here. Can anybody remember? What's cosine of pi over 2? That's 90 degrees.
Is it 3 pi over 2? No.
0.
No, I believe it's 0, yeah. So you can, a lot of people learn this in a lot of different ways. Some people memorize values around a unit circle. For this one, I just would remember the shape of cosine looks like this, where that's pi over 2. And the value of cosine of pi over 2 is 0. So this is negative 0. And then minus cosine of 0. Actually, my picture gets you that one also. Cosine of 0 is 1. So this is 1. So my answer is 1. All right? So this is one situation where I would want you to simplify the trig functions. And I will say this, if I ask you a question like this on one of the tests, I will say specifically, simplify all the trig functions in your answer. Because that actually is something important that we're going to need to know how to do as we go forward. All right, so let me just write this down. You should know sine and cosine of important values. The important values are 0, pi over 6, pi over 4, pi over 3, and multiples of those things. Also, 2 pi over 3, 3 pi over 4, pi, etc. These are the standard values that people learn for points around the unit circle. You should know all of those. Some of them are like root 2 over 2, which you can write as 1 over root 2. That's fine with me. And so on. All right. We have a few minutes on the clock, but I think I'll leave it at that. And if anybody has questions, one thing I didn't mention about the syllabus is I would be happy to talk with anyone who feels maybe you are getting a feeling at this point if this is the right class for you or not. If you're not sure, depending on your major or whatever, let me know and I'd be happy to chat about it. See you all tomorrow. No homework due this week. It'll be next Wednesday.